everybody, welcome back to our 11.6 notes. Yet again, I lost track of time and got stuck mid-problem when the last one ended. So we're going to pick up exactly where we left off. Where we left off, we were graphing this g of x function, which was x squared minus 2, and we had already made a table with x and y values. So we were in the middle of plotting. We already have -3, 7, -2, 2, -1, -1, and now we should also have 0, -2, 1, -1, 2, 2, and 3, 7. We'll connect our dots to form a nice U shape, which is our parabola, and we'll notice that yet again, it has the same shape as the regular x squared, it just got moved down 2. So when you have something that's added or subtracted at the end, that's what it does, is it moves it up or down. So I'll make a little note here that x squared plus 3 moved up 3 from our regular x squared graph, and x squared minus 2 moved down 2 from our regular x squared graph. Okay. The next thing we're going to look at is, what if that plus 3 or that minus 2, what if that's inside of the parenthesis instead of outside? Does that have a difference? And it does, actually. So we're going to see what that does. And I'm sorry about the formatting over here. This should be x minus 2 squared for f of x, and x plus 3 squared for g of x. Okay? So let's try a few and graph it and see what it looks like. So we're going to start out with if x is -3, so if I do f of -3, what I'm really doing is I'm doing -3 minus 2, and then I'm going to square it. Okay? -3 minus 2 is -5, and -5 squared, so that's -5 times -5 is positive 25. Okay? If you do the same thing for -2, you would have -2 minus 2, which is -4, and then we'll square it, and -4 squared is positive 16. Okay, I'm going to give you guys a minute and see if you can fill out the rest of this table. Make sure that we're feeling comfortable doing that. So, yet again, pause the video, and I'll fill out the table with you in 3, 2, 1. Alright, for -1, you should get 9. You should have 0, 4, 1, 1, 2, 0, and 3, 1. Let's see what the graph looks like for that one, okay? So 25 is not going to fit on our graph, and neither is 16. But the first one that's going to fit on our graph that I have over there is -1, 9. So we'll plot that. Then we have 0, 4, 1, 1, 2, 0, and 3, 1. And it looks like a J, doesn't it? But it is going to be a parabola, and if it makes you feel a little bit better, we could actually finish it up. Because you notice that it goes down, and we start going back up again. So we notice that here's where our new vertex is. Okay? So it shifted. It used to be at 0, 0, and now it's at 2, 0. It moved to the right 2. But that's the new axis of symmetry. It would be right down the middle here at 2 through the vertex. And then if you would like to make those mirror images, we certainly can. So this is 3 away. We'd count 3 away and go on the other side, and you can complete your U if you'd like to, complete that parabola. And so what I notice is that x minus 2 graph is that x squared graph. It just got shifted over to the right too. I'm going to let you guys try the next one all on your own. So the other one we have over here is x plus 3 squared. See if you can fill out the table, and then let's see if you guys can graph it and figure out what's going on, okay? So yet again, pause the video, and I'll show you what the answers are in 3, 2, 1. So your table should have 0, 1, 4, 9, 16, 25, 36. Okay? So then graphing wise, you're going to have -3, 0. You're going to have 2, 1. You're going to have -1, 4. You're going to have 0, 9. And then everything else is off your graph. And so you only get half of your parabola. Okay? Did anybody figure out how to get the other half? So our vertex used to be at 0, 0, right? And this plus 3, instead of moving it right 3, it actually moves it left 3. That's your new vertex. Because you have nothing that moved it up or down to change the y value of the vertex. We only had the plus 3 here with the x to move it left 3. And so if you would like to complete the other half, this is our axis of symmetry, and we can complete the other half. So we have the same y values, and it's the same distance away from our axis of symmetry, and that's what it looks like. There we go. Alright, so let's summarize what just happened there, okay? So the f of x graph, that x minus 2 squared, what happened from the original is that it moved right 2. With the x plus 3 squared graph, what it did is it moved our x squared graph, and it moved it left 3. Okay. So it's basically acting like our x value is 3 bigger than it actually is, or 2 less than it actually is, and so that's why it's moving it. It kind of feels like it's the opposite of what you would expect. With a minus 2, you would think left 2, but it's not. It's doing the opposite of what you think it is. Okay. So let's summarize all of that on the next page. Okay. So general principles for graphing quadratic functions. Okay, so the general format that we're going to use is this vertex form. Okay, and this is what it looks like: is f of x equals a, that's some number in front, x minus h squared plus k. Okay, and of course a is not going to be 0 because then you wouldn't have an x squared term. So that the shape, that u shape, is called a parabola. The vertex is going to be at hk. Remember how it was normally at 0, 0? But the h moves it left or right, and the k moves it up or down. And so then it's moving that 0, 0 point around. So our vertex is at hk. And keep in mind that h is going to be the opposite of whatever you see in there because it's x minus h. And k is going to be exactly what you see at the end because it's plus k. Okay. Then we also have this axis of symmetry that we've been talking about. And that axis of symmetry is always a vertical line, and it always goes through our vertex. So if it's a vertical line, that would be an x equals equation. And it goes through our vertex, which means that it goes through the x-coordinate of our vertex, which would be h. And so we're always going to have that line that's an axis of symmetry, and you can always do mirror images on either side of it. Okay? Let's see, the graph opens up if a is, might be able to answer this one, positive. And it opens down if a is negative. Okay, you guys remember how that negative x squared, it flipped it around? And then, honestly, you can have other a values than just -1. You could have -2, which would flip it and stretch it. You might have -1/2, that would flip it and shrink it. Okay? The graph is wider than f of x equals x squared if we have those smaller x values that shrunk it, that shrunk the y values, okay? So that would be if the absolute value, because I'm not talking about signs, that was to talk about if it was up or down. I'm just talking about the magnitude of that leading coefficient. So it's wider if it's small, if it's less than 1. So remember how like that 1/2 out front made it wider? That's what we're looking at, okay? The graph is going to be narrower if we have big A values because that stretched it and made it narrower looking, okay? So if the magnitude of A, so I'm just talking about magnitude, not signs, is greater than 1. Okay, and of course if it equals 1, then it is the x squared graph shape. Okay, so with all of that in mind, let's try one. So the first one I have is f of x equals x minus 2 squared plus 3. So what I can tell you is that the a value is 1, which means it's going to be the same shape as our x squared graph, and it's also going to open up. Okay? The minus 2 is going to move everything right 2, and the plus 3 is going to move everything up 3. Okay? So I'll make a note of all of those things. So same shape as the regular x squared graph. Okay? But we're going to move right 2 and up 3. Okay? So just identifying some things. The vertex, instead of being at 0, 0, guess where it's going to be now? It's going to be at 2, 3. That axis of symmetry, I'm going to use an AOS for axis of symmetry, is going to be the vertical line that goes through our vertex. So that would be x equals the x coordinate from our vertex, which is 2. Okay? And let's go ahead and graph it from here, and then after we graph it, we'll talk about domain and range. Okay? You could talk about it probably beforehand, but I think it's nice to have that visual. So let's start with our vertex. Our vertex is 2, 3, so I can start there. And if any point you're thinking, how in the world is she doing this? It's too complicated for me. You can always go back to making an XY table, and life is going to turn out just fine for you, I promise. Okay? But it is nice to know where your vertex is so you know which x values to choose. Okay? But from here, what I think about is those regular x squared points. So the 0, 0 became 2, 3. Another easy one was that 1 squared was 1. So I used to have a point at 1, 1 right here. But what I'm going to do is I'm going to take that point and go right 2 and up 3, and that's my new point. Or if you want to think about from the vertex going over 1 and up 1, you can. And then there's a symmetric point on the other side. Okay? There used to be a point at 2, 4 right here. But what we're going to do is take that point and go right 2 and up 3. And then again, there's a symmetric point on the other side. And so that's a really fast way to graph our quadratics, is by using what is called transformations. If you know this stuff, if you know your regular x squared graph and what we're doing to it, you can graph much, much faster. Okay? In case you're curious, the axis of symmetry is right here. It goes through 2. It's a vertical line. Okay? It says to also give the domain and range for each function, so let's do that. The domain for this one, what x values can I use? All of them. Or if you want to look on your graph, how far left do I go? There's an arrow. I keep going forever. How far right do I go? There's another arrow. It's going to keep going right for forever. So that's all real numbers, or negative infinity to infinity. The range for this one is what y values we get. Or if you want to think about for our graph, we're saying how far down do we go? We start at a y value of 3. And then how far up do I go? The arrows tell me I keep going up for forever. So our range will be from 3 to infinity. The 3 does have a bracket because we're including that point, and it is part of our solution there, okay? You could honestly answer these things before graphing it if you would like to. I know that my domain's all real numbers because you can plug in any x value that I ever wanted to. With the range, once you know that where your vertex is, remember range deals with y values, and you know that our shape is going up, then you know that this is the lowest y value and it keeps going up for forever. Okay? We will continue one more video to do the last 3 examples, okay? So tune in for part 3.